Okay, so welcome to the first episode that we're going to be doing in the C# Tiny Room Simulator as opposed to the one that I'm doing concurrently side by side, the Bolt Tiny Room Simulator. I'm going to be doing the exact same thing in both just to kind of show you whether you want to use Bolt or whether you want to use C#, you can achieve the same thing in both. So this little room I created in the previous video using Bolt, so all I did was just model this really quickly. Nothing special, just a box that's been extruded. I just added a little window, assigned 3 different materials, one for the floor and one for each wall. And I also just created a canvas with a single button on it. I just called this one bed. I'm going to switch that out later on for whatever I need. But the whole concept of this series is that I'm going to create a little tiny room simulator. So I can click bed, add a bed to the room, rotate it, place it, that sort of thing. Next one, maybe add a cupboards, side tables, lamps, that sort of thing. Paintings on the wall, rugs on the floor. Just so that it's a really fun way to learn to code, and it's also, you're not bogged down with the concept of having to come up with like game mechanics that are balanced with game design and level design and all that stuff. You're just making a little experience where it's fun to kind of populate your room with some assets, focus on understanding the lighting in Unity, materials, that sort of thing. So we're going to do the same thing we did in the video that's been uploaded on YouTube. We're just going to do it in C#. So if I go to the scripts down here, you can see I've already got the 2 Bolt ones. I'm going to right click and create a new one, and this time it's going to be for, call it UI button, and that's going to be the C# equivalent. I'm going to assign this script to the button. Oops, I already have one, so let me just make sure I remove both of these. Will it let me remove? There we go. Let me just remove both of these and just add a new one. I'm not quite sure how I added another one, but I did. Okay, so let's open up the script, and I'm going to be opening it up in my visual script editor of choice, which is going to be Visual Studio Code. It's just a lot lighter and just opens up really, really fast. Okay, so looking at this, you'll see that there's similarities between Bolt and the coding. One might be node-based, but they both start out with the same default script when you create it. It's got a start and an update. So I'm going to remove these because I don't need them for the time being. But I do need a variable to store the reference to the object that I want to instantiate into the world. So I'm going to make this a serialized field because I want to be able to have it accessed in the editor by the artist, but not necessarily by anything else or any of the other scripts. So it's just going to be a serialized field. It's going to be a game object. I'm just going to call this, let's be very descriptive, object to spawn. There we go. So that's the variable I'm going to use. And for the time being, we're just going to test to see if we're going to instantiate it, and then we'll progress forward to the next part of the script. So I'm going to make a public void, and we're going to call this on button click. Let's just call it something like that. On button click. I'm going to add 2 curly braces after that. So on button click, this is a method that I'm creating. It's my own method that I will be calling when I click the button on the UI. And it's going to do whatever's in this between these 2 curly braces, this one here and that one there. So for now, I just want to instantiate. For those of you, instantiate just means to essentially make a copy or a clone of the object that's in your project, in your scene. Okay, this one's going to be, just going to call it object to spawn. Now I'm not too bothered about like position, rotation, all that stuff. Normally an instantiation requires you to say, this is the object I'm spawning, then where am I spawning it, and at the same time, what is the rotation of this object? Because I'm going to be using raycasting to move it around and reorientate the object, I'm only going to instantiate into the world, and that's all I really care about from this at this moment. Now that we've done that, we're going to go back. I like to test my code as I go just to make sure everything is working. So if we click on here, you'll see we have a new variable that is exposed in the editor. Remember, this is a serialized field. And I'm just going to grab the prefab I originally made. If I drag this prefab in, you can see it's just a little bed. So I'm going to grab that as the object I want to spawn into the world. So I'm going to grab my prefab from the project on the left here, drag it across, and replace it on the actual variable on this UI button. Now, if we try to do it now, we're going to click the button. Let's just do it so you can see that it doesn't work. When I click the button, I can spam it and nothing actually happens. The reason for that is this function I've created isn't actually being called. Sorry, this one here. So I need to call it when I click the button. So that's why we made this function public, so I can actually access it from outside of the script, which we're going to do here. Now, the easiest way to set up a button, if you're not very comfortable with code or just very comfortable with using like listeners and buttons in code, is simply by going to the button and looking in the button script that's Unity has. At the bottom there is an Unity event called onClick, and it says that currently the list is empty, so I'm going to hit plus to add a new one, and all we need to do is specify which object or which script we want to talk to. So in this case I'm going to grab, literally it's actually right underneath it, so I'm going to grab the UI script and drag it into where it says none object. And over here, you'll see no function is no longer grayed out. I'm able to click on it. Then I'm going to go down to my script called UI button, and I'm going to look for that on button click. That's the function I created over here. So on button click. Sorry about that. So this should work now. So if I start the game, I'm going to be able to press the button, and now I've instantiated a bed right in the middle of the room. I can't move it around or do anything like that, but at least I know that every time I click this button, I'm just going to be spawning a new one. So now I've got 2 beds, they're literally on top of each other. If I click it again, 3 beds, 4 beds. So we know that this part of the code is working. So we'll come back to this code when we have more to work with, but right now we're going to leave this. We need to go and actually create an empty game object in the scene that I'm going to, and I always like to reset the transform. So I right click and reset it, especially if it's an object that's not visible in the game. It's just going to hold scripts on it, just so that I can manage things. I'm going to rename this to Tiny Room Manager. And this is going to hold a script that's going to take care of the ray casting. It's going to take care of all sorts of things. It's going to do a lot of different this is essentially going to be the little manager that manages all the elements of the game. So I'm going to right click in the scripts folder and create a new script. I'm going to call this one Tiny Room Manager. Wait for it to compile. I'm also going to maximize my Unity. I'm not sure why it wasn't. And I'm going to drag the script onto the Tiny Room Manager game object. There we go. So it's there now. We're going to open up that script inside of Visual Studio Code, and for now I'm going to do most of my calculations and logic inside of the update. So I'm just going to select and delete the rest of it, and we're now going to start with the variables that we need. So first of all, I need to make sure that I need a bool that's going to check to see if I click the button, I want to be aware that I'm placing the object. So I need to have a bool that will ask, am I currently placing the object? So we're going to make this public bool, and let's just say is placing. There we go, and put a semicolon. So that is it. For those of you who don't work with this kind of code normally, if you make it a bool and you leave it by default, it's going to be false by default. So don't worry about, unless you want to be 100% safe, you can always just say placing is equal to false. Whoops, there we go, and then it will set it to false over there, just as a failsafe. So we'll leave it like that for now. The other one is I want to make a reference to the object I've instantiated in the manager so I can move my object around based on the object that I've spawned. So we're going to make another variable that's public, bool, and this one's going to be, not bool, game object, what am I saying? And this one's going to be, let's just call it currently selected object. There we go. It's a little bit verbose and it's a little overwritten, but I'm okay. I can read this and make sense. So this is the currently selected object, so I know that this is the object I want to move around the scene. Okay, next one is, this one can be a serialized field because I just want to have access to edit that in the editor. So this is going to be a layer mask, and we're just going to call this a layer. What this layer is there for is I don't necessarily be able to put a bed on the wall or put a carpet on the wall or maybe even put a painting on the floor. So I'm going to use this layer to be able to manage where items should be able to be placed as opposed to where they shouldn't. So that's what this layer is here for. So we got a few things to do, but I'm going to work out the logic and then I'm going to show you at the end how we're going to make this script visible to this script. So this script's going to need to, the UI button script is going to need to be able to talk to the tiny room manager. But let's do all the logic and then we'll come back to the end for full circle to do that. So in the update, I want to ask a question. I'm going to do an if statement. And in the if statement, first I want to see if it is placing. I want to know if I'm placing an object. Now, we can do two types of things. We can do a nested if statement. So if it's true, then I'm going to do a raycast. Or we can do the raycast and the nested if statement at the same time. So we're just going to do it that way just to make things a little bit less complicated. So I'm going to create a localized variable or a throwaway variable over here. It's going to be a raycast hit. I'm just going to call that hit. We're going to use this now. You'll see what we're using. So we're going to ask, is placing true and physics dot raycast. We need to add 2 round brackets because this is a function we're calling. If you hover over the actual error where we're getting where there's the little red squiggly line and everything, it says we need an origin, we need a direction for the raycast, we need a distance at which the raycast will stop. We need to know the layer, and we can also add an out hit, which we don't see here, but I'll show you how we're going to do that. Okay, so this is kind of this is a isometric game, so using an orthographic camera. So I'm going to keep it nice and simple. I'm going to say camera.main.screen point to ray. This works really well, and for the most part only actually works with orthographic games. Other ways to do this raycast would be to get the camera, for example, get screen point to world, and then raycast in the camera forwards. But we can also do another video on that if you guys want. So what screen point to ray asks is, I've got the camera that's tagged as main, where all I need now is the location from where on the screen to raycast out away from the camera. And this one, in this case, is simple enough. We're going to say input dot mouse position, because we want to get where is the mouse cursor at the time and raycast from the mouse cursor. So now we have the position and the actual raycast direction. So after that we need to go comma, and we're going to actually specify the out hit. So we're going to type in out, and remember that variable we created called hit. So what that means is whatever the raycast hits, I want to store into this variable called hit. So in the if statement, I need to get some information from the object that I hit or the location that I hit. Okay, so out hit, comma, and for now, lazy programming, I'm just going to put in a value for how far the raycast should go. I'm making it about 100 meters. I know it's excessive, but we can probably go a lot smaller than that. And then we need to do one more thing. We need a comma, and we need to type in the layer variable we created. Okay, so let's go through this again. This first section here is finding where the camera is, finding the position of the cursor, and raycasting from the camera position in the direction of the forward vector of the camera. Then we're saying, okay, if you hit something, store that value as an out. Remember, the raycast should only be 100 meters into the world in my case, so you can make it whatever you want. You can make it infinite if you really want to. And then the last one is, what layer am I listening for? What layer am I hitting? Okay, so remember, this is a double-barreled if statement, if you will. Is placing has to be true, and physics.raycast has to come back as true as that it hit something. If it did, we're going to use that current selected object dot transform dot position is equal to hit dot point. Semicolon at the end. Now, if you're wondering where I'm getting this transformed opposition, if I go back to Unity, all objects in Unity, if they're inside of the inspector over here, have a transform right at the top here. So I'm basically saying, let's pretend this is the room for now. Select the room, find the transform component. That's why I'm saying room, basically currently selected object dot transform dot position. You'll see a transform is made up of a position, rotation, and scale. That's all I'm doing, is I'm basically saying whatever's on the left side of the equals, please be equal to the right side. And if you're not aware of it, a position is a collection of 3 floats which make up a vector 3. And so is a hit point. The hit point is, best way to explain it is, I hit a ray cast out, it hit a vector in the world, a vector 3, and I'm saying move my object to that location in the world. That's all I'm doing. Okay, now that we've got this, it's going to work. We're going to have to do a few tweaks, but I just want to go back to what we were talking about earlier, how I'm going to make this script accessible to other scripts. So I normally put this right at the top of all the other variables here. So we're going to call this public static, and you normally call this variable by the script you're trying to reference. In my case, it's Tiny Room Manager over there. I'm just going to call this, give it a name. Let's just call it instance, because that's what it's going to be. It's going to essentially become an instance of this script. So what we're doing here is we're saying, please create a variable that is static and it's public of type Tiny Room Manager script, and I'm giving it, in this script, I'm giving this variable a name called instance. Okay, so what it's going to do is when you start the game, we're going to have to go onto the awake, and on the awake, if this script exists in the level, we want to say instance is equal to this script, so that when I want to talk to this script, all the other scripts are aware that there is an instance of this script in the level somewhere, and we can talk to it. Okay, so as we do this, this will make a little more sense, but this is the way you make a script accessible to other scripts. But it's a twofold process. First, you've got to make a public static, reference the name of the script over here, and give it your whatever name you want to call it. And then down here in the awake, normally you say the name of the variable you just created is equal to the script that it's currently in. Okay, we're good to go. So let's go back to the button. We have to do a few things in order for this to get to the point where we can actually use it correctly. So when we click the button, I want to instantiate this object, but while I'm instantiating it, I want to tell the manager that this currently selected object has to be equal to the one that we're currently spawning. So in front of the instantiation, I'm going to call that Tiny Room Manager dot, remember we called it instance dot, and I can search for currently selected object is equal to this object here. Now, if you're wondering why it works, is because remember I'm instantiating a game object, and the variable in Tiny Room Manager is also a game object. So all I'm saying is that bed that I'm instantiating currently, please set the currently spawned bed to be the object that the manager knows is the currently selected object. Okay, so next thing is to also now search for the Tiny Room Manager again, instance dot, and remember that is placing variable we created. We're going to set that to true when we click the button, so that all I'm saying is, okay, when I click the button, I want the Tiny Room Manager to be aware that I'm currently placing something. So when this goes true, if we go back to the Tiny Room Manager, this variable becomes true, and that means all I need to do now is start raycasting to see if I hit something, and if I hit something, we can actually move the object around the level. So let's test that out. Okay. As a start, I will show you this again. I'm going to select my floor in my model and make sure that I have a layer here in the top right called floor. So the way I created this floor layer was by going to add layer. Let's pretend it will look like this when you first do it. So I'm going to type in floor, and then I'm going to select the floor again in my hierarchy over here and just assign the floor layer to the default layer over here. And I'm going to do the same thing in my manager. So I'm going to select my tiny room manager, and over here you'll see that there is a layer here. It's currently set to nothing. Let's select the floor. Great thing about layers is you can select multiple. You can say I want to cast for the floor and default maybe. And then whatever objects are in default or floor will be able to give me a true value for my raycast. Okay, so let's see what happens here. I'm going to hit the bed button. Notice how the bed, now I can move the bed around. Notice how when my cursor leaves the floor, the object no longer moves until I bring the cursor back onto the floor, and then it continues following. Remember, our raycast said only if the raycast actually hits the floor will this object move. And I'm fine with that. For now, I'm good with that. I'm good with the fact that my bed stops moving the moment I'm no longer raycasting. But here we go. The bed is moving around. I want to be able to, when I left click, I want to drop this item into the world. I want to stop moving it around. Let's go do that code, and then we're pretty much done for part 1, and then we can move on to part 2. So let's go back to the code, and we're going to do this in the tiny room manager. So in the update, underneath the first if statement, we're going to create another if statement. And where it says true, I'm going to say input dot get mouse button down, 2 round brackets and 0. So what that's asking is, have I pressed the mouse button? And is the mouse button 0? So the best way to understand the way Unity's mouse buttons are set up, 0 is your left mouse button, 1 is your right mouse button, and 2 is your middle mouse button. Now, while I'm here, I'm going to do another double barrel situation and ask it again. I'm going to say and is placing. So I only want to do this if I press the left mouse button down and is placing is true. If that's the case, I'm going to say is placing is equal to false. There we go. That'll do it. That'll be for the first part. We can test it to see if it works. We're going to push play. I'm going to hit the little button to create. The bed will be in the middle of the room. If I decide to drop it right here in the corner, I can drop it. There we go. If I create the next bed, I can add a new bed. Now the problem with our system, and we're going to have to develop this as we go, is I can place one bed on top of another bed. So I can keep filling this room with beds with no consideration for whether they're going through the wall or whether they're going through each other. But we'll continue collision detection, that kind of thing, in the next video. But that's it. Thank you so much. Keep an eye out for both of the videos, the Bolt one and the C#. So that was the C#. I've now opened up the Bolt one, and you can see we can do the exact same thing in Bolt. So here's the button, there's the bed moving around. I can essentially just do the exact same thing both in Bolt and C#. Thank you so much for watching, and keep an eye out for when the next video comes out. Thank you.